a rod now. I'm going to release it. Simple idea based, nothing to do. So even some fuse concept can also be brought here. That's the main idea of this question. Let's get it. So initially I'll release from rest. So what are the force that will be acting? Mg will act. So then it'll start accelerating. That mg will be continuously be acting. No? I think now directly get into the thing that one. We have discussed some problem. I think if you can remember some standard formulas, the standard conclusions will be much easier. If a rod is pulled by a constant force, then the velocity at any instant of time will be. Finally, after a long time, mg should become equal to bil. Say in exam, if you want, you can use the conclusion, because after a long time we know that. So after a long time, yeah. Okay, this will be mg, and there's a terminal velocity, I infinity we used to call it. Straight away you can get that particular condition, that one. So mg is equal to, and it will be moving with a constant velocity. So mg equal to bi infinity L, and it will behave like a cell. So let me draw it. So it will behave like a, yeah, this will be better diagram for us. Now come for this one. So what is I infinity? Again, it will have EMF induced E infinity. So that E infinity should be equal to BVT by L. That's the terminal velocity. And therefore this I infinity should be equal to E infinity by R. Substituting that. This is a terminal velocity. So the expression for speed as a function of time, how that equation will, it will end up like this, no? Let's not bother. Find the minimum mass of the rod that will ensure that fuse blows out this one. So this is the expression for V. Then what is the expression for I? I will be BL V by R. Since he has given values, it will be easy for you. I just discussing theoretical. So what will happen to current also? Here also it will increase with the time. The current also will definitely increase with the time. Fine, the current will increase exponentially with the time, and finally it will become constant. If there were no fuse, if there were no fuse. Okay, now this is V. This is current I infinity. Now you see this. So current will continuously increase, no? So once the current through the circuit becomes 4 ampere, the fuse will blow it. Find the minimum mass of the rod is asking. So how to bring that into the picture?
Maximum current should be greater than 4.
What happened?
Maximum current should be greater than 4.
See, once the current through the fuse just greater than 4, it will blow out. So there's the maximum current, that one. So is now the whole system is uniformly is telling. So where do that find the minimum mass of the rod that will ensure? Minimum mass is telling. It didn't say that one. So shall we take this to be 4 ampere?
Yes, sir.
Yeah, this terminal current should be 4 ampere. I think that directly what happened, this you can put it here, no? So if you put this 4 ampere, then look at the M, the relationship. I think we should take this one only. So the value of M will come. So the value of M should be less than that particular value. I need not to do all this. Actually, you could have started from here only. So I'll get into the question. So mg equal to bi infinity L. So that is equal to, so what is I infinity? So I think we have equation here. So you, I think, okay, I think I'm messing up. Huh? Directly I infinity, you write 4. So what is value of B? 1.5. 4 length of the rod, 0.5 G 10. So what you get this M should be minimum value of telling. So M greater than that, it will blow out, no? So take equal. Anybody value?
0.3.
This is the idea of this one. Okay, some any of things. So it's not just only motional EMF. Different other things will be definitely will be dumped. You just be careful. Tomorrow you just remind me that 5 questions I have to discuss. Very good questions are there. Some nice ideas are there. Because they'll be useful for advanced. No, that's why they took today. Okay, revise all the content. Eddy currents also.
Sir,
Ah,
once can you open spherical capacitor sum, sir?
where it is? Oh, spherical capacitor sum.